what I love about this is the fact that these aren't like the Martian meteorites or some of the more esoteric meteorite types that a lot of the studies are being done on. This goes back to previous work that was done on a meteorite that I'm actually holding in my hand now. It's called Zag. So this fell in the Zag region in Morocco in 1998. I don't know if you can see that there clearly, but that's what's called fusion crust. So that's the the outer part of the asteroid or meteorite. Meteor as it hits the upper atmosphere starts to ablate, and basically you get this dark crust material, and then the meteorite can shatter in the upper atmosphere, fall as tens or hundreds of stones. Heavier pieces tend to go further down what's called the strewn field, and then you find all sorts of pieces. Now, Zag itself is only what's called an H5. It's an ordinary chondrite. It's nothing spectacular, not like, say, the Murchison meteorite, for example, which is more of an interesting type. You've got some of the amazing carbonaceous chondrites like Allende that's been studied since 1969. So this fall, late 90s fall, H5 chondrite, nothing spectacular. But then when it was analysed, there was organic matter again found in this. They found what they call these cold clasts. So it's almost like a rock within a rock. And within that, they found evidence of amino acids galore in this thing. It's an absolutely fascinating area, and you look at comets and you think, well, we know that there's lots of organics in comets, as Terry said before. The work from Chandra, Singh, etc., at Cardiff University. This is going back years and years in terms of the idea of panspermia and life being deposited on the Earth from an extraterrestrial source. And you had the red rain incident in India a few decades ago, etc. I love this, that meteorites, which are kind of always considered to be the kind of the boring part of the solar system relative to comets. The comets have got the organics, they've got the tails, they're spectacular as the meteorites. Asteroids not so much, but they're proving to be more and more instrumental, and not just the unusual asteroids, etc. As I said, it's the common, chondrites and the carbonaceous chondrites, not so common, obviously, which are delivering this really interesting set of results. This one, some of the class that were analysed, they think it was kind of outer solar system, a really early outer solar system formation material that got kind of embedded in there. So there's probably going to be a lot more work done now on the likes of Zag and a few of the other meteorites. As Terry said, some of the pristine sample return missions that are coming back, they're going to be open season for this kind of work. So I love this story. It's just going to run and run and run. And as you said, this is one of the most fundamental questions for anyone on this planet: is where did we come from? Where did life come from?